Hello, everybody. Welcome to this week's GeoAI Bytes, regular live streaming sessions sharing industry observations, tech tutorials, ML models based on current events, and much more. I'm Dan, your host for today, and the content marketing manager here at Pictera. Now, today, we're going to dive into all how GeoAI is not just shaping the future of mining, but also revolutionizing it. And joining me today is Luke Hopkins, our customer success team lead here at Pictera. Now, Luke has a deep understanding of GeoAI applications in mining and has been instrumental in helping our customers leverage Pictera's platform to achieve truly remarkable results, which we'll see today. Luke, great to have you with us today.
Yeah, thanks, Dan. I appreciate it, and pleasure to be here. I think this is an important topic, and something that we've seen with our customers in the mining industry is really that we're kind of on the cusp of a technological revolution, and I'm excited to discuss how GeoAI is playing a pivotal role in that. And I think with Pictera, we've seen firsthand that incredible impact of these technologies in overcoming challenges and optimizing operations.
Yeah, absolutely. And that's exactly what we're here. And hopefully, you guys are here to learn about today. Now, we're going to be looking at some groundbreaking use cases where GeoAI is really making a significant difference. So, from exploration to environmental monitoring, we're going to cover the entire spectrum of applications that are not just enhancing efficiency within the industry, but also driving sustainability within mining operations themselves. Now, towards the end of today's presentation, we're particularly excited to share how absolutely anyone can create these powerful Geo AI models using Pictera, especially without the need for any complex coding skills. So it's all about empowering you, the professional within the mining sector, to harness the true potential and the power of Geo AI with ease and precision. So whether you're a geospatial analyst, whether you're a mining engineer, or simply just someone passionate about the intersection of technology and mining, you're in the right case. Now, before we dive into the first use case of today, we're going to set the stage a little bit with a little brief overview of Geo AI and exactly why it's a game changer within the mining industry. So, taking this step back, Geo AI really stands at the intersection of geospatial data and artificial intelligence. Really powerful combination that's reshaping how we approach mining operations. And it's about leveraging this cutting edge technology to address some of the most pressing challenges that the mining industry faces today. You'll see on screen now we have how we add value across the mining lifecycle from exploration, planning and design, construction, production, and up to closure and reclamation. Now, the sector itself is really at an inflection point. So, grappling with the need for sustainable development, of course, the increasing complexity of exploration, and the imperative for operational efficiency. So, these challenges are not just obstacles, but they're actually opportunities for innovation using Geo AI.
Yeah, and I think just to jump in there, Dan, what we've seen from working with our customers is that sustainability is a prime concern within the industry, and I think the environmental impact of mining activities is under constant scrutiny. So this really drives the need for solutions that can ensure that operations are not just efficient but also environmentally responsible. And I think GeoAI offers a path forward which enables more precise environmental monitoring and impact assessments as well. And I think kind of expanding on that within the exploration space, so one of the sections you can see on the diagram at the moment, I think exploration is another area where GeoAI is really making its mark. And I think what we've seen is the traditional methods of identifying mineral deposits are becoming less effective and more costly as well. So with GeoAI, we can analyze vast amounts of geospatial data to help uncover insights that perhaps lead to more targeted and successful operation efforts as well.
Yeah, exactly. And I think operational efficiency is another area where Geo AI can really shine. So from optimizing mining operations to predictive maintenance of equipment, the technologies that we're using today help mining companies do much more with less. ensuring that any resources are used effectively and that their operations run as smoothly as possible. So with this backdrop of GeoAI's growing importance within the mining industry, we're going to dive a bit deeper now into some of these use cases, and we're going to see examples of them on screen. So these examples will not only highlight the transformative potential of GeoAI across these various aspects that we can see of mining, but also illustrate how Pictera as a platform is enabling this revolution. So with that in mind, let's dive in to our first use case, and that is water body mapping. So Luke, can you help us out here? Can you share why this is such a crucial area for enhancing safety within the industry?
Yeah, absolutely. So one of the examples you can see on the screen, like Dan said, is water body mapping, and these water bodies can come in sort of multiple different formats. It could be creeks, it could be the open pit mine pooling, and potentially tailing dams near mining operations. And this really causes or poses a significant risk to the safety aspect of those within the mine site. And I think especially we've seen in regions where water bodies can freeze and then get covered with snow, you need to make sure that you've accurately mapped these and identified these before that happens, so you can make sure that you've planned for the safe operations during that time, and making sure that no one's going to be driving one of these several ton vehicles across a frozen lake, essentially, in some cases. So it's really important to know where all of these are prior to that.
So I guess that's particularly important in remote, difficult to access areas where mines obviously often are. So it sounds like quite a challenge. How does GeoAI fit here? How does it change the game?
Mm-hmm. Yeah, so it offers a powerful solution by using both satellite and drone imagery to map and monitor these water bodies in almost real time. And this means we can get accurate, up-to-date information about the presence and the dynamics of water near mining sites, which allows for the timely adjustment in operations to avoid these safety hazards that might be there.
Okay. And then potentially how significant is this impact on the purpose of operations within a mine?
Yeah, the key impact we've seen, or the few key impacts we've seen, is the ability for mining companies to develop in-house solutions, which gives them full control over the analysis process as a whole. And I think this is powerful because it ensures that operational continuity can happen, and this enables mining activities to proceed without unexpected disruptions due to these water-related hazards. And on top of the safety aspect, it's also about making sure that you can seamlessly integrate this environmental monitoring into the daily operations of those that are going to need this on a regular basis.
Okay. And you mentioned that ability to develop an in-house solution. So what are key advantages of doing that rather than an external provider, let's say?
Yeah, one major advantage is the cost efficiency, and this provides a more affordable solution for the operations as a whole. And I think this is kind of important when you've got lots of different mine sites, and you need to monitor large areas at potentially the same time. I think another is the capability, should I say, to detect smaller water bodies with the same resolution. And this really ensures that you've got this detailed mapping of the entire mine site to give you this complete overview. And this is kind of coupled with the rapid processing of large mining areas for timely analysis, because this is obviously needed as soon as you can really get it, once the imagery is collected. So really important to be able to process that quickly. Additionally, I think the versatility to provide consistent data products across different sites whenever they have imagery ensures that this uniformity in monitoring efforts is seen across all of the mine sites. And I think, well, lastly, an interesting application that we've actually seen from some of our customers is bird deterrence as well. So by accurately monitoring and mapping these water bodies, companies can take proactive measures to prevent wildlife from interacting with these hazardous areas.
Okay, so kind of what I'm hearing as well is that it's more than simply just about the cost, which obviously is an important factor. It's about versatility, speed, environmental responsibility as well. And with the example that we can see on screen now, can you explain a little bit what's going on?
Absolutely. So you'll see that we've got kind of a GIF on screen with the green striped areas flashing up. So this image at the moment is actually our detector training view. So I'll be showing this towards the end of the presentation, but this is the interface in which you will build your detector. And what you can see flashing is one of our testing areas, which shows results from the model as it's being trained. And this is used kind of primarily to make sure that your model is performing correctly, and also gives you the ability to then improve on this as well.
Awesome. Okay. So let's move on to our second use case now, and this is around area feasibility assessment. Now, this process is vital for understanding the potential impacts of a new mine on the surrounding area. So can you break down the challenges, Luke, for us that are involved within assessing an area for a new mining site?
Yeah, absolutely. And there's a number of things that you need to make sure that you are assessing correctly when determining whether there's kind of a potential for a new mining site. So I think it's crucial to comprehensively understand the area's current use and kind of the objects and the features that you see within that area at present day. And this includes some of the objects that you can see on screen, but this includes the locations and the extents of housing, forests, agricultural fields, and existing infrastructure as well. So that might be roads or other kind of methods of transport in that area. And the challenge really lies in accurately identifying these features to assess the impact of the new mine, which again is essential for planning, meeting environmental, social, and governance targets, and determining compensation levels as well.
Complex task, pretty significant implications here. So how does GeoAI fit in here? How does it assist in addressing these specific challenges?
Yeah, so it significantly simplifies this task. So by utilizing satellite imagery for sort of land classification, this really allows us to identify various land uses and features as well from a broad perspective. For more detailed analysis, especially in areas where objects like buildings or roads might be obscured by vegetation, then higher resolution aerial imagery can also be used. And this dual approach ensures that we have a clear, accurate understanding of the area, which again is critical for assessing the feasibility and planning for these new mine sites.
And again, what's the impact here? So what are we looking at after we've implemented such a solution? What can we expect?
Yeah, so what we've seen is a profound impact. So by employing GeoAI for your area feasibility assessments, mining companies can make these informed decisions that align with sustainability and community considerations. And this approach, it not only helps in planning for the physical aspects of the mine, but also in addressing social and environmental responsibilities as well. So it's really about ensuring that new mining projects are both viable, responsible, and also sustainable from the get-go.
Okay, great stuff. Thanks, Luke. Now, a bit of housekeeping before we move on to the next use case. Anyone watching live today, don't forget you can put our questions to both myself and Luke via the platform of choice where you're watching from today, like LinkedIn, YouTube, X, or Facebook. Just pop those questions into the event page and they'll come through to us. We'll answer them at the end. But next up, we have a use case that really focuses on a crucial aspect of mining operations, and that's maintaining up-to-date maps of haul roads. So the condition, the layout of in-pit roads can change pretty frequently within a mining site due to various factors, including seasonal impacts. Now, Luke, can you talk us through why actually keeping an up-to-date record of these roads is so important within mining operations?
Yeah, so keeping accurate records of these in-pit roads is critical for several reasons. And I think firstly, for emergency access and response. You can imagine if the roads are blocked or unsafe due to ice or water concentration or perhaps other hazards, then it can significantly delay emergency services getting to the place that they need. And if that road has changed since you last documented it, then it could go down a completely wrong road as well. Secondly, I think the road maintenance and analyzing this across the entire site is vital to ensure that all vehicles, regardless of size, can navigate the mine site safely, which leads me onto a requirement that we're seeing actually more regularly now is the use of autonomous vehicles around the mine site, which, as you can imagine, are even more dependent on these up-to-date haul roads to navigate the site, because in some cases they don't even have anybody on board, no personnel on board, so there's no one that can say, no, sorry, you shouldn't go down that road in real time. So it's really important to make sure these are up to date as much as possible. And I think the challenge is that these roads change so frequently, and making traditional mapping methods or using traditional mapping methods to do this is very resource intensive and often outdated as well.
And so with that in mind, and with the dynamic nature of these mining environments, then staying current is a real challenge. So where does GeoAI step in here?
Yeah, so it primarily streamlines the process by allowing us to detect and map these in-pit roads accurately. So by running these models on a regular schedule, we can keep our road records up to date with minimal manual effort. And really, it's a game changer for ensuring the safety, which I mentioned, and also the efficiency of mine site operations. So you can see on screen that one of the stats we had there is in this particular customer's case that it prolonged the wheel durability by 1.5 times, just because they weren't going down the wrong roads and they would accurately get into their location that they needed to. So by creating these road detection models on Picterra and running them regularly, mining companies can establish a robust monitoring and maintenance process as well. And really, this not only ensures that you have these accurate haul road records, but it also enhances the traffic management around the site as well. And again, emergency response planning, I keep coming back to it because it's a real important one. And it's all about maintaining these high safety standards while optimizing the operational efficiency.
Okay, awesome. So looking at our final use case today, and moving on to this one, we're looking at the intersection of both mining operations and environmental stewardship. And we're looking here at invasive species management. So invasive species can pose significant risks to, of course, local ecosystems, and then by extension, to the operations, the reputation of mining companies. So what are the challenges that invasive species present within a mining site?
Sure. So invasive species can really disrupt the local ecosystems that you see around the mine site, or kind of prior to the mine site. And you'll find that these often outcompete the native species, and then this leads to unintended environmental consequences around the mine site. And for mining operations, this can affect land reclamation efforts. It can affect biodiversity goals. It can even affect the sort of the operational permits that are allowed around that mine site. So the challenge really lies in detecting and managing these species early enough to prevent their spread across the mine site, which, as you can imagine, is quite difficult over large and often remote areas as well.
Yeah, and I mean, significant implications here for environmental management, for compliance as well. So how does GeoAI help with this challenge?
Yeah, GeoAI offers this powerful solution by enabling the detection and monitoring of invasive species across extensive mining sites and areas using both drone and aerial imagery. And by analyzing these images with machine learning models, we can identify the changes in the vegetation patterns, which are often indicative of these invasive species as well. And kind of the most important part is providing a solution that will allow us to get this early indication of these of these invasive species, and therefore allow us to intervene. And I think producing these management strategies that can be implemented really minimizes the ecological impact and ensures that you're complying with your environmental regulations as well.
And then leading on, I mean, what are some of the benefits that you'll see of using GeoAI for invasive species management?
Yeah, so the benefits can be significant. I think firstly, it allows for continuous monitoring of vast areas, which is, like I said, critical for this early detection of invasive species. it also supports informed decision making regarding the intervention and management strategies of this, and it really ensures that your efforts are both targeted and effective, so that you're kind of eradicating this before it becomes a much larger problem than it is. I think ultimately this really helps mining companies to protect the local ecosystem and meet their environmental obligations as well, which obviously maintains a good standing with regulatory bodies and the community.
Yeah, for sure. Now, we've seen some really great use cases and examples, and we've seen some screenshots of Pictera and the platform in action. So you might be wondering now kind of how these models are actually built within the platform. Do I need specific data science background? Do I need coding knowledge? All these kinds of questions. So Luke's going to drop into a bit of a demo for us and give us a bit of a crash course into how to actually set up some of these models that you see in these use cases. But before he does that, a quick note about supported images, actually, Luke. So if you wouldn't mind just kind of walking us through, we've seen a few different examples of perhaps satellite and drone imagery, but actually it goes a bit further in terms of the supported images that you can use to build a model, right?
Yeah, absolutely. And like you said, we've spoken about several different types and sources of imagery that you've seen kind of throughout this presentation and that you see on the screen at the moment. And again, I just wanted to highlight that Pictera has the capabilities to cope with these different imagery types and sources as well. So in a lot of cases within the mining industry, objects or land covers that you want to detect or are of interest can be extremely difficult or even impossible to detect using just RGB imagery alone. So when creating detectors within Pictera, you can actually utilize more than just the 3-band imagery, and the platform will automatically look through all of the bands available within that image to determine the best differentiating features kind of that object or land cover. And this will help the model to provide you the best results possible.
You got it. Now, this stage, I think everyone's pretty keen to see how exactly these models are made, and it's in a surprisingly quick time. So, Luke, I'm going to hand it over to you now and give a quick whistle-stop tour of the platform.
Thanks, Dan. So what you're seeing at the moment is our Pictera dashboard. So there are several features on here that you would become more familiar with, and this would fill up when you're using the platform more. I'm going to, like Dan said, give you a very whistle-stop tour of how to actually create a detector and begin adding annotations. And I'm more than happy to give a more detailed demo after this call if you get in contact with us. So the first thing that you would need to do is create a project. This project houses the imagery, and I will choose water bodies in this case, and I already have an image uploaded. Once I've uploaded that image, I will then begin creating my detector. And a detector in Pictera speak is a machine learning model. All I have to do is name my detector. I'm choosing segmentation in this case. I'm going to select my training images from the project that I mentioned. We will choose this one. And once you've added that image into your detector, we can click next, and we'll come into our detector screen. So this screen that you're seeing at the moment is the interface that you will be building all of your detectors on. And like I said, I'm not going to go through every single tool on here. I just want to show you how you would begin annotating and telling the model what it is that it's interested in. So the first thing that you would do is create a training area. So we'll draw across like that. This training area is essentially guiding the model's attention to this box, and then we will tell it within this box what is of interest. So I've got 2 different ways of telling the model by creating 2 different drawing tools for telling it. The first one is a manual annotation, which is clicking around the water body, like you can see me doing here. It's always good to be as accurate as you can. I'm going slightly quicker than I would normally for the sake of this demo, but you can see here we now have a green outline. So the model now knows that everything in this green area that we've highlighted, this is of interest, and this is what it should be learning from to deliver you results. The second method for creating annotations is our magic wand. So once this initializes, it's going to allow us to do one or a couple of click annotations to actually build the knowledge of the model. So as you can see, it's now initialized. So if I click in the middle of this water body, you'll see that it's produced me an outline in blue. Now, if I'm happy with that outline, I can either press enter on my keyboard or submit under here. And this will create an outline for me, which in this case is a lot easier than manually clicking around that entire water body. Now from here, I want to show you a more complete example of a detector. So I will jump into our water bodies detector here. Now, you can see on screen at the moment that there is some more annotations and there is also some more colored boxes. The second box you might have seen in that initial slide on water bodies, and this is purely showing us results of how the detector is performing. You will also notice that we have our accuracy areas, and these provide us results, the polygons in the striped pattern, on top of our ground truth, the block colored outlines. And depending on how well they match up, gives us our accuracy score and tells us how well the model is performing. Now, the final thing I want to show you is our dataset recommendation report. So what this report does is allows us to tell how well the model is performing and also how, or the areas in which we need to add more data. So by generating this report, it's going to break the image down into these tiles, essentially. So these different colored tiles, and each tile is broken down and categorized into that color based on how it looks and the similarities it has with the other tiles in the image. So this can be really handy to help us understand whether we've got a good training coverage and a good accuracy coverage or a bad one. So that what you can see here is all of these tiles broken down into the different clusters. So you can see we've got our blue cluster here, our yellow cluster here, red in the left, and green on the far right. So what we want to do is make sure that we have a good orange kind of haze covering across all of it, because it means we've got a good training coverage, and also a good blue accuracy coverage. So at the moment, I could say, well, my model, it's got a good training coverage because it had the good orange coverage, but the blue coverage is lacking. So what that report will then do is produce you pins onto your image itself. So you see we've got a yellow pin here and a blue pin here. And this is giving you suggestions on where to add more data into the model itself. So like I said, that was a very whistle-stop tour of how to create a model and the tools you can use within the platform to improve it. I think I'm passing back to Dan now.
Yep, thank you, Luke. That's awesome. So we're moving towards the end of the time for our session today. So we'll open the floor for any questions you may have about anything that we've discussed. And so we will keep an eye on those. Again, as a reminder, if you're joining us via LinkedIn, Facebook, X, or YouTube, you can submit your questions and they'll come through to us here. And I do see a couple that have come in whilst we've been talking. And actually, someone mentioned I noticed the accuracy score in your demo there, Luke. So they noticed the accuracy score was 93%. So the question is, how do you ensure the accuracy of these models? Are there any steps that are taken to improve them over time?
Yeah, absolutely. And I think one of the methods is that dataset recommendation report and making sure that you have good accuracy coverage across all of your image to start with, because then it shows that you have a model that is a good representation. So you could imagine if you put just one accuracy score in one corner of the image, then it's not going to be representative of how well the model is actually performing. But following those steps of creating more training areas in the areas that the model suggests can also improve the accuracy score as well.
Okay, fantastic. One is related to the imagery. So we saw the supported image formats earlier, but someone's asking around the resolution in terms of if they're using maybe open source sources or they're using commercial data providers. Is there a minimum resolution that's recommended for use within the platform and to build these kind of models?
Good question. And I think it comes down to the object or land cover that you're interested in. So you can imagine, and kind of what our golden rule is at Pictera is if you can see it in the imagery, then you can build a model on it. You need to be able to see it to build a model on it. So if within your imagery resolution, your object or your land cover of interest can be seen, then that works for us. But there isn't a restriction on what resolution you need or what resolution works within the platform. We're agnostic, if you like, on resolution, and also we're agnostic on the image source. So if you are getting your imagery from one of the satellite providers or you're getting it from a drone provider, that's okay. You can upload it directly into the platform. You can connect to WMS and ArcGIS servers and where those kinds of things where you host your imagery, and you can also connect to your imagery via a public URL as well.
Okay, great. And actually, following that similar theme on integrations, someone's asking if these models can be integrated into existing operation systems they have in place or existing workflows that they might have.
Absolutely. So Pictera has a REST API that you can connect into. So we have the ability to make this a seamless workflow right from detection through to analysis in another platform if you choose to do that. So we are very open, and a lot of our customers have embedded Pictera into kind of a longer workflow.
Okay, good stuff. I think that's it for the questions that I'm seeing coming through on the chat now. If you do have any final ones, make sure to get them through to myself and Luke now. But otherwise, once the session has ended, we'll keep an eye on the various social pages and platforms that this is going live on to answer any follow-up questions that anyone may have. So with that in mind, all that remains is to thank everyone for their attendance, for their participation. Big thank you as well to Luke. Thank you for taking us through those great use cases. And we'll see you next time for the next GeoAI Bytes session. Thank you again.
Thanks, everybody.
Bye now.